have 6 plus 4 equals 10, which we have 6 red dots represent 6 and 4 blue dots represent 4. And then a student can just add them up and that equals 10. And then we did 4 plus 6 equals 10. So 4 blue dots represent 4 and 6 red dots equals 6. So that added up to equal 10. And it's just a nice grid for students to be able to understand the problem. So what we have today is each of you will get your own set of dots, which we have represented as M&Ms. Yay. And each of them will have you, they each have 2 different colors in them, and you will write your own mathematical equation according to your colors. And what we encourage you to do is also, like, if you have it start with, like, if I had, we started with 6 red dots and there's 4, then we encourage you to, like, reverse it too, so that they can understand the commutative property.
So essentially the number of dots doesn't change, it's just the color that represents the number. Did everyone get one? Did you get it?
So it also just shows students that order does not matter, and it provides visual, and as each of you can see, or do all of yours add up to equal 10. So they all add up to equal 10, but did having a different color change that? No. And then did having like the different numbers, like if I had 2 and someone had 7, did that, or 3 and someone had 7, did that change it? Okay. And then this is their definition. It's for look for and make use of structure. It's basically how shapes and numbers are organized. And the characteristics of this, of MP7, is operating, dissecting, discovering, deconstruct, decompose, and compose. And it basically incorporates the mechanics behind a problem. And then we go into our sample problem.
Okay, so here's one of the sample problems. It's a little bit more advanced than the M&M problem you guys just did. For example, we did 19 plus 51, but we thought of it differently. So basically, you're going to keep breaking it down. So you're going to think of 19 as 10 plus 9, and that equals 19. And then you're going to think of 51, which is either you can do 5 10s, so 10 plus 10 plus 10 plus 10 plus 10 plus 1, or you can think of it as 50 plus 1 to get 51. So then essentially you're going to just combine those. You're just trying to break it down so where it looks easier for your eyes. So then you would group them as 10 plus 9 plus 50 plus 1. And then if you want to even go further from there, you can think 9 plus 1 equals 10. So you could just do 10 plus 50 plus 10, and that equals 7. So when teaching, you can ask questions like, where have I seen this before? How can I break it down? How can I make it easier? And so forth. So basically, essentially, you just try to break it down and make it easier. If you wanted to make it more advanced, you could incorporate like more operations like multiplication, division, parentheses, just make it difficult, I guess.
So then we incorporated our adaptations for K through 6. So students can think more just than the numbers. Students can think about color, appearance, and visual representation like we did with the M&Ms. And then we can also give students extra time to process the information by just giving them the example ahead of time. And then letting students know that struggling is okay when going through the structure of a mathematical problem, because it is difficult. And then giving students brain breaks, because when they become flustered with following the structure, it's important that they are able to come back to it and approach it in a more positive way. And then also giving students individual instructions, which we found to be important for, especially ours, was just making use of structure, because everybody understands math in a different way, and now, as you can see, there's so many different ways of solving a problem. This is why, like we did our 19 plus 51, students see it differently.
Okay, so We incorporated a couple standards for lower elementary grades to kind of show you how structure works. Basically for kindergarten, you should focus on two things. So basically we're representing, comparing whole numbers or shapes, things like that, and looking at things as a whole in the end. And then, like it says, describing shapes and space. For first grade, you should focus on developing understanding of addition, subtraction, multiplication, and division, and how basically that can be incorporated into bigger problems as well. As far as like for the structure though, it just depends how it's set up. But the initial goal is to try to make it easier for you to solve. For our SIOP, for kind of like what I just explained with the kindergarten, first grade, the lower elementary grades, they're focusing on adding and subtracting, so they're going to need prior knowledge of smaller numbers and how that they can combine to make bigger numbers. Vocabulary would include, if you're doing a word problem, more than, the sum of, less than, so forth. Upper elementary grades, they're starting to multiply and divide, so their prior knowledge is going to be also addition and subtracting, but I guess more in a complex way of how they can make that bigger just using a different technique.
Okay, then we also put in how we have the self-questioning strategy for use of structure by them being able to acquire the information and take it in. And then we did the how SIOP explains like the aha moment where the teacher previously discusses with the terms that they'll be using, and that will get them interested and motivated, especially with like when they start going into subtraction. They'll be able to see if we just did how the order doesn't matter for addition, when we start going into subtraction, order does matter to make sure that we have a positive number, so we can explain that further with being able to discuss previous terms. And then we can also give students a form of activity by just working with smaller numbers with using our that we use. And then we can also incorporate the UULB strategy. We're having the student, like how we kind of did it with our M&Ms, have them write down their own equation and then work out with their peers with like their shoulder partner and having them compare their equations and then working it together as a class by what did you all end up, what were your answers and how it varies from person